Alright, so I wanted to talk about absolute value signs and Dirac's Bra-ket notation. Um, Neither of these actually make sense in the way that everything else works around them. Um, and no one seems to notice or care. Quite the opposite. People think these are good ideas. Right. So first off, let's just look at absolute value, right? We will say that, say, the absolute value of 24 is 24. The problem here, and for clarification, say, the absolute value of 17 is not 17. If you get something like this from your equation, you would call this an extraneous solution. The problem with this one should also be extraneous. Because when you write this at the beginning of a phrase, like this is written, like this, 24, this means positive 24. Absolute value is unsigned. Okay? You cannot do addition and subtraction with unsigned numbers, right? 4 minus 3 equals negative 3 plus 4 because we're working with the unordered list of integers, positive 4, negative 3. This is both spell outs. You can order it as 4 minus 3 or as negative 3 plus 4. Regardless, the negative sign always goes with the 3, and the positive sign always shows up when it's not in initial position. It doesn't show up in initial position because our default assumption is that whatever we're working with is positive. So if you don't have to write it, we don't write it. In initial position, we don't have to write it. Oh, fuck me. Alright. So, this 24 up here, that's in an initial position, we are assuming, based on this grammatical rule of mathematical orthography, that an initial positive is not written because the default assumption is that an unmarked value is positive. Okay? And this is a normal grammatical rule. One of the problems that Giuseppe Peano ran into here, and nobody seems to have noticed, is he fancied himself a really good linguist. Most linguists do, and most linguists are morons. But Giuseppe Peano was ahead of his time in this, because he was truly nowhere near as intelligent as he thought he was, nowhere nearly as well educated, well informed. Given the standards, he probably was well educated, but he was not well informed about how languages operate, and he grossly overestimated his comprehension of how these things work. Right? He is the individual who launched the idea of a universal language. Right? Think about the hubris involved in that. Right? What kind of solipsistic jackass you have to be like, oh, I'm smarter than the entire history of the human race. I can make a language that's better than what everyone else has done. Think of how asinine that is. How arrogant. That's some shit, right? This dude did not understand his place in the world. He did not understand that he is not God's savior to humanity. He didn't. that tradition is definitely alive among linguists today. But fuck me, Giuseppe Peano had this in spades. Okay, so what he did when he looked at something like, oh, that's okay, 4 plus 3, he's like, okay, well, what's happening here is the plus is the verb, and these are the nouns, right? So this is the operator, okay? On first blush, this is totally plausible. I actually bought this for a very long time. But it doesn't work, okay? Because, so that's why this is interesting that 3 plus 4 and 4 plus 3 are the same thing, right? And we get into the idea of like abelian groups and all this bullshit. Because if that's just an operator, well, why doesn't the order matter? That's really interesting. Well, the order doesn't matter because that's not an operator. The order doesn't matter because what this is this is the pair of the unordered list of integers, 3 and 4. So that the reason that those are the same is because we're just walking through some vectors. It's like a grocery list, your shopping list, right? You go to the store, as long as you get everything on the list, it doesn't matter if you got milk before you got eggs or if you got eggs before you got milk. When you walk out of the store, you got all of the things, and that's what matters. And that's why this does this. And if you account for things correctly, the commutative property operates exactly the same over subtraction as it does addition. But we didn't account for it correctly, so it's more interesting that, oh, it appears in addition, but it doesn't appear in subtraction. Nah, it's because you did it wrong, dumbass. Because if we do this, 4 minus 3, well, look at that, how do we turn a subtraction into an addition? No, dumbass, watch this. You didn't, because there's no operators here. Okay? Watch. This is exactly the same symmetry that you have with addition over here. These are the same thing is happening. Okay? Now we get to the problem here, right? You cannot add and subtract bare dimensionless numbers like this. Absolute value of 24 plus 7 doesn't even make sense. Because what is this? This is this. This doesn't make sense. I don't know what direction the 24 is going. Because it doesn't have a direction by definition. It doesn't. It's just a number. It has no direction. We've conventionalized the notion that the positives are the bare numbers, but that's not really true. That's a cultural artifact. Okay? And you can you can see that Peano's account of things doesn't work because, so, say we've got, there was a lot of effort put into this, put into 1 plus 1 equals 2, right? First off, if Peano's axioms are valid, well, okay, if they're sound, then you don't need to prove this because it's given to you by definition via the successor function. You don't need to prove it from your axioms because it's made from your axioms like instantly. Anyway, everyone's like, oh, ready to prove this. Okay, so there's a red flag already. But in order for this to work, there's something that has to happen here. Okay, so this is only true when the units on each of these things is commensurate. So one 1 mile plus 1 mile is 2 miles. Yes, that's true. But 1 dog plus 1 quail is 6 legs. Or 1 cup of water plus 1 cup of dirt is some mud. Or 1 frog plus 1 pond is 1 pond. So now I've got, well, 1 plus 1 is 2. Oh, here, let's do another one here, just to illustrate the depth of the problem here. 1 dog plus 1 quail is 2 wings. I have a conventional set of these, and I just don't feel like going through all of them right now. Okay, so we can get 1 plus 1 is 2 because our units are commensurate, and it actually added up to 2. We can get 1 plus 1 is 6 because unit changes, unit conversions. We can get 1 plus 1 is 2, which is the exact answer that we want. This one right here, right there. That's the answer that we want and expect, but here we get it for the wrong reason. We get it because 0 plus 2 is 2. Right? When we do our unit conversions, we don't get that 1 plus 1 is 2. We get 0 plus 2 is 2. Right? So this is an identity. Whereas the other one was the first 1 plus 1 being 2 when it's miles. That's using, arguably, Peano's successor function. Right? They work for completely different reasons. Okay? Or we can have 1 plus 1 being undefined, really. If you put a cup of water into a cup of dirt, you don't get 2 cups of mud. You're going to get more than 1 cup of mud, but you're not going to get 2 cups of mud. It's going to be somewhere in between, because the water is filling air spaces between the grains of dirt or sand or whatever the hell right? You're not getting 2 cups of mud. You're getting some mud between 1 and 2 cups. It's undefined how much you're going to get. Don't know. So 1 plus 1 is undefined. Or we can take a frog and throw it into a pond, and now you just have a pond, because frogs already live in ponds, so you didn't change anything. Or, like, you can take a rock and throw it into the ocean, and it's still the ocean, because the ocean is huge and there's lots of rocks in it. Adding a rock to the ocean didn't fundamentally change anything. It's still just the ocean. Right? So 1 plus 1 can be 1. It can be undefined. It can be 2. It can be 6. It can be 2. And those 2 different 2s are... One of them is... Only one of them is coming about the way that we expected. Right? So you end up with this problem that 1 plus 1 overall is just as undefined as division by 0, actually. But we do have this nice case where what we're doing becomes well-defined, and that is when the units on all of our terms are identical, or at least commensurate. Right? When all of the units on our terms, the terms on all of our units is commensurate, then we get well-defined solutions. The problem now is Giuseppe Peano claimed that this works over natural numbers. Natural numbers are what you get out of an absolute value here. Absolute value of 24 is the natural number 24. It doesn't have a sign. It's not positive. It's not negative. So up here, saying that this is an extraneous solution, absolute value of 17 is negative 17, saying that's extraneous, but not saying that absolute value of 24 is 24 is extraneous. That's a mistake, okay? Okay? Absolute value, the magnitude, is strictly the number part. It does not have a sign, okay? But Peano's axioms require us to be operating, in order for Peano arithmetic to work, we have to be operating with vectors fundamentally. Which means it doesn't work over naturals. Which means Peano was wrong. Right? Because the only place where Peano's conclusions work, where the successor function works, isn't over naturals. It's over at least integers. At least integers. But the way that it's set up, it's specifically supposed to be giving us the naturals, and the integers are supposed to be derived from them. That is not possible. Okay? The naturals are not a subset of the integers because the integers are signed. The naturals are not. The naturals are bare magnitudes. The integers are vectors. They're signed one-dimensional vectors. Now, where this gets even stupider is we come to Paul Dirac. Okay? So we get Bra-ket notation from Paul Dirac. And the point of this, the point of Bra-ket notation, for the most part, and you see it in quantum mechanics. It's like standard notation in quantum mechanics. And I can't quite do it in plain text, but it'll be something like this, right? This is kind of a standard argument here, right? That ket 1 plus ket 2 may not be ket 3. Because these things in the ket are vectors. Usually complex vectors, right? So they're like matrices, right? But guess what? One plus 2 may not be 3 anyway. This did fucking nothing. Arithmetic naturally operates over vectors. So marking when you're using vectors in your arithmetic is dumb as fuck, because it means you don't understand what you're doing. So we have this notation for marking bare magnitudes, which we virtually never use bare magnitudes. And when you do, it kind of doesn't matter because you're using it in a multiplication. And the way a multiplication, so like a term where all of these parts are multiplied together, you get to choose which part of that is the magnitude, honestly. Right? So, say we've got like 14 root 2, let's make it I, sure, why not? It's imaginary. 14I root 2 times x. And it's, say it's negative, and this is in meters per second. Right, there's a lot of parts to that. What's the magnitude on that? The answer is yes. Yes. The magnitude is any of those, honestly. We could treat x as the magnitude. We could treat 14 root 2 as the magnitude. Fuck, we could treat root 2 as the magnitude. We could treat I as the magnitude. We could treat the negative 1, in a sense, as the magnitude, or per second, or meters. Because everything in here, this is just a jumble of crap that's multiplied together. Any part of that we can separate off, we can call it the magnitude. Okay, any part of that we pull off and we isolate, and you're like, okay, this is our magnitude. And the rest of it is still a vector. Because it still has some magnitude and some dimension on it. Even if it's just 1, just positive 1. Positive 1 has a unit and dimension. Or, yeah, has magnitude and dimension. The magnitude is 1, and the dimension is positive. We can pull 1 out of that and say that's our magnitude. But you still can consider it to be a vector, the leftover part, because it's still the unit positive 1, which still has a magnitude. Right? Units by definition have unit magnitudes. So you can't really ever get rid of the magnitude fully. So this is dumb as shit. We have these two notations that we rarely use, but one of them we don't ever need to use. The Bra-ket notation, we don't ever need to use this because we're always working with vectors, doing any arithmetic or above. We're always working with vectors. The absolute value, the magnitude, that's the one that we should be much more careful about and actually use much more widely. Because what we're doing is we're getting these conflations of, well, an absolute value of 24 is positive 24. No, it fucking isn't. It isn't. There's also this problem that we don't have categories for bare magnitudes because of the way set theory was evolved. We say that, well, the integers have a subset of the naturals, so the naturals line up with the positive integers. No, they fucking don't, because they don't have a sign. They're perpendicular to the integers. They're a different thing from the integers. They're distinct. But now, if you want to take, say, the absolute value of pi, what the hell do you invoke for that? What category do you invoke? Because, yeah, I can clean this up a little bit for you and be like, okay, so the naturals they're distinct from the positive integers. Okay, they don't have a sign attached to them. But how do you conceptualize pi now? What the fuck is this now? What is the absolute value of pi? Because this needs to be unsigned magnitude pi, not a vector. How do you do that? We don't have a way to indicate this. There is no conventional way to indicate what this is. But Paul Dirac is worried that, we need to make sure that we're indicating when we're working with vectors, even though we're always working with vectors, dumbass. Like, this is so broken. How? How is it this broken? This is amazing. How wrong the conventional way of doing everything is just how did you manage to be this wrong about everything? God damn it.